in. So these are all the operations. So these are all the operations that was related to the stack. And have you seen a real-time example where the stack has been used?
Yes, sir.
Where? So I had tell you that stack which is
Tennis rocket, sir. Shuttle.
where hello?
Tennis
This
shuttlecock, sir. In a box.
shuttlecock
We are
box. Okay.
inserting. Yes, sir.
Yes. Yes. Good.
Memory management, sir.
Memory management. Yes. Good. Any other thing? Yes, sir. Yes. Good. Have you studied that? So that will be very fine. And here in this stack, you all know that will be a last in and first out. In the first unit itself, you have studied. I hope so. You have. I hope so. You will be remembering this, right? In the first unit, you have studied this, right?
Yes, sir.
Yes.
Yes,
In the
sir.
first. Yes. In the first unit, the process which will be the condition whatever we have discussed in the first unit, that will be the same. The last in first out process, you want to push the element from the one end, and the same end will be the deletion process will be there. We can insert or update in the middle of the stack, or else you can push or pop, whatever it may be. The process and the conditions what we have discussed, that is stack, want to create a stack and push, pop. We want to display the top element of the stack. You can check whether the stack is empty or not, and you can find out the stack size, and or you can assign the stack size. That is, if you are assigning the stack size as 10, and what will happen, you can only insert the 10 element in the stack. If you are inserting the 11th element, it will show that the stack is full. Like that, it will show. That will be depends upon your program or whatever you are writing over there. So that is the basic thing we have already studied, and we have seen an example of a stack by using an append operation, push functions, like that we have studied. So we will recall those things also, and after that we want to discuss about how this stack will be used in a linked list. So as of now, what we have studied, we have write a simple program to create a stack and then push an operation or pop an element from the stack. And in this class, we are going to study about the stack operation which will be implemented in the linked list. So it may be any type of linked list. It may be singular, circular, or doubly, whatever it may be. So today we will discuss about the singular linked list. That will be enough for the stack process. So have you all aware about the linked list, right? What is meant by linked list? Yes.
It shows the address of the department.
Yes, it will be yes, it will be having a connection between the two nodes with the related to the address. It has been classified into three types: singly, multiply, and doubly. So this stack, you know the concept of the stack, as well as you know this concept of the linked list. So here we are going to merge those stack into the linked list. So that is the concept. And before going to that, as this is the basic thing why we are going to study. So this thing I want to explain in the first class itself. So now I am going to tell that. So anyhow, the data structure which will be going to deal with the data, so that you are aware about that. And here, how the data want to be used, and how the data want to be stored, and how it will be processed, and how to gain the knowledge from those data. And the final thing, it will be how the data want to be maintained secretly. So these are the things we are going to, in the data structure, that the data we are going to dealing with those data. And here we are going to study the two types of things: how to store a data and how to process it. The storing the data, you can store the data like array, tuple, dictionary, whatever it may be, you can store the data. But the process thing, it will be consist of a list, and the list we are going to study. We are studying in this second unit, and we having some building blocks also. So building blocks in the sense we having a number of ways to store the list. So this is known as the building. Why? Because I am telling this. These are all the 2-mark questions that we are going, that we will expert in the university point of view. If you in your question paper, if they are asking what is the data building blocks, then you will be worried about that. So building blocks is nothing but the list, how you are going to store the data, and there will be different types of building blocks will be there: linked list, circular linked list, singular linked list, like that. The linked list will be there. So based upon this linked list, we are going to build some of the blocks by using those data. So this is the thing, and here we are going to study about the stack. And you all know that a stack is a collection of objects that are inserted and removed according to the last in and first out principle. And a user may insert an object into a stack at any time, but may only occurs or remove the more recently inserted object that remains. So recently inserted object will be your last object. So that object want to be remains. That object want to be removed first. So that is a concept. And the list which will be inserted or deleted allowed only at one end of the list. That is the top of a list. You can push or pop the element from one end to another, one in the same end. So that is the thing. So I will share you this slide also. So now going with an example. Have you seen this text editor? So this is a real-time example. If they are asking for a real-time example, you go with those text editor also. That will be a very good also. So have you used those text editor, Word, Notepad, and PowerPoint and all?
Yes, sir.
Yes, yes. So what is meant by the undo mechanism? Undo mechanism.
Sir, it deletes the last element.
Yes,
Sir.
last
Last word.
last word. Whatever the word. If I am typing this, whatever I am word. If I am typing this, if I am typing here as data structures. So if I am typing as some other content I am typing. If suppose I am giving the undo option, the last word whatever I have typed will be removed. So if suppose I am giving this. And typing some other things. Suppose I'm giving the control Z option, whatever I have typed last, that will be removed first. So that is the real-time example. If they're asking example of a linked list or a stack, you just write a real-time example of that. And here the internet web browser stores the address of the recent visited site in a stack. Each time a user visits a new site, that site address is pushed onto the stack of address. The browser then allowed the user to pop back to the previous visited site using the back button. If you are using if you are searching any content in your Google, if you are clicking the back button, what will happen?
Goes to the previous page, sir.
Yes, it means the last page what you have visited, it will go to the last page. So it means that it will store in a stack, and the previous page it will be viewed first, and after that the next previous page it will be viewed first. So likewise it will be there. So when they are asking for an example of this, you just write an example like this, and a lot of examples will be available in your Google. You just search those examples, and you are aware about any one or two example for a stack of process as well as the queue process, right? Yes, the stacks are simplicity of a data structure, yet there are also among the most important. The formula stack, which consists of, there will be a basic of two methods will be there in a stack. One is push and another one is pop. So here, basic methods will be the push and another one is pop. So these are all the two methods that we are going to use. And already we have discussed some of the problems related to the push and pop methods. Have you remembered that? To add an element, we use to push, and to remove an element at the end, the last element you want to remove, you can use the pop methods. And apart from that, we are going to use the top function, top method. That means it will display the topmost element. That means last inserted element in the program, and it will is empty. That is, yes is a stack. So here the function will be is empty. It will return whether the stack is empty or not. If it is yes, it will return true, or it is false, it will return the false statement. And we can find out the length of the stack, whatever the n number of element you have inserted. And if you are not assigning a stack length, then if you are inserting n number of element in between your program, you can find out whether the length of the program, length of the stack is wherever you need. You can find out the length of the stack by using this function called length of yes. Yes, in the sense it is a function that we have already used. That is a variable that was already declared. So this is an example. And these three types will be very important to do a stack operation. That is push, pop, top of the stack, and you want to check whether the stack is empty or not, and you want to find out the length of the stack. And here I am giving a sum of an example. You can see about this. So this is an operation that is yes. Yes, in the sense it was a variable that yes is a stack that we have already applied. So this is an example. So s dot push of 5. It means the stack content will be 5. Before that, the stack will be empty. First push value is there, so it will be 5. And push 3. And the length of the stack, we want to find out that length of yes, and it will return the value of 2. So it means we're having a 2 variable, so it will be returned the value of 2. And s dot pop in 5 and 3, the 3 has been popped, and the remaining value will be stored in the stack. And here we are going to check whether the stack is empty or not. So s dot is empty, so it will be returning the value of false because we're having a value 5, so it will be returning the value of false. And again we are popping an element of popping the next element, that is 5. So now the stack is empty, and here we are checking whether the stack is empty or not, and the value will be true. And there is no element in the stack, and we are popping an element that will cause us of error. So likewise, the sum of an operation I have given here. So I will give you 1 minute time. You go with those operations, and you can ask me if you are having any doubts in those operations. So based upon this operation, we are going to do a program by a linked list. Clear? This is a basic example. If they are asking, not ask in your exam point of view, if they are asked to explain the lines, if you are asked to explain the stack with the operations in your 8, if you are getting those question in your 8 mark, then you can write the program. If you are getting the question in a 4 mark or a 2 mark, then you can write a basic operation and you can give a result. That will be enough. So based upon your marks, you can write the content over there in your exam point of view. Have you clear about this? What is happening here?
Yes, sir.
Yes. So, yes, before going to that, before going to that, what we want to do, so don't go with those lines of code. You don't bother about those lines of code. Before going to do a linked list operation, first what we want to do is we want to create a stack, right? Yes.
Yes, sir.
We want to create a stack and we want to print a stack. So these are all the functions that we want to describe in your program. First, you want to create a stack, then you want to print a stack, and push operation want to be there in your program, and pop operation want to be there in your program, and the top operation, it means the topmost element want to be displayed in a stack. So top element want to be there. So these are all the basic things that will be involved. These are all the basic functions that will be involved in your program. So just aware about what are the functions that will be involved in your program. Don't go with those lines of code. When you are practicing those lines of code, then it will be very easy for you. But the concept want to be very clear. So when you are writing a stack program, first you want to initialize the stack, and you want to print the stack over there, and three operation will be there: push, pop, and top. For this 3 operation, you want to write a lines of code. So this is the blueprint of the program for the stack in the linked list. So I will show you one of the things. So this is the program we have already discussed. So can you tell me what is happening here? Yes, there's no time.
Sir, we are creating stack, sir, and adding some elements using append
Yes.
function.
Yes.
And after that, we are printing stack, and after that, we are using pop function, sir, to delete elements.
Yes. So yes, good. So this is the thing. What we have done is we have created a stack, and we have appending a function, and after that we are popping 2 functions. So it means that C and B will be popped out, and it will be displayed, right? So this is the basic thing. Without using a linked list, without using a list, we have created one stack function over here. And whether we have created any list over here, linked list. Whether we have created any linked list or we used an array function.
No.
Yes, we have not created any linked list because we are going to create a linked list in your lines of code will be different. So here we have not created any linked list over here. Just we have created one array. In that array, we are adding an element and we are popping out the element. So this is the process. So now coming to this program. So what is happening? So don't go with this. So see this lines of code, that will be enough. And you can tell me whether we have created any linked list over here. We have created any linked list.
The only list we are creating.
We have created
We
a
have
list.
declared self dot stack is equal to list.
Yes, we have created a list, but we have not created a linked list, right? And we have setting the maximum size is 8. It means that the maximum size of the list will be 8. It means that stack. So we are creating a list and we are setting a maximum sizes list of 8 and we are creating a stack. And the top element will be 0, that we have not initialized any element. So the top element will be 0th element. So likewise, it will doing a program. And I will share you this lines of code. You do an operation. So it will be a basic stack operation, not as a linked list operation. So we are doing a push operation over here and pop operation, and the size will be displayed at the top at the end of the thing. So here we can give a number of condition, push, size, pop. Likewise, you can give a number of condition and you can print the result also. In this also, we have not created a linked list. We have created a list that to inside a function. It means a constructor. Inside a constructor, we have created only list, not a linked list. List in the sense all the elements are combined together and make the process. And linked list with the sense it will be having an address of the next element that will be useful when that storing purpose will be occur. So here we have not used any linked list. We have just created a list and storing the process. And here you can tell me what is the thing. So this also we already discussed. Whether you have created any list. So I'm telling you the difference between the normal stack and the linked list stack. So that's why I'm asking that n number of same concept, but the n number of methods, definitions, and the functionality will be there. And the only thing, if they are asking you a question in first unit, then you can go with this lines of code. It means that you no need to worry about the list process and all. You just declare a stack and do an append, push and pop operation, and you can display the size. That will be enough. If they are asking you the question in the second unit, definitely you want to be in the linked list concept. So that's why I'm giving you a lot of examples. So see this lines of code, whether we have used any list over there, linked list.
No, sir.
No, so it means we have created only function. So we have created only function. Inside the function, each and individual function will be called. Inside the function, we are using the stack, and again we are using an array. Based upon the array, we are pushing an item and popping an item from the array. So that is a concept. So now you can see this, whether we have used any list over here, linked list.
Yes, sir. Using class.
Yes, sir.
Yes, you can see here I already told we want if you are using this data and the next. So for creating a linked list concept, this class will be used. The constructor will be defined, and after the constructor, the data and next process will be happening in your program. It means that we are using a linked list concept. But based upon these conditions, you can tell that in what type of list you are using. Based upon the condition, you can tell over this. But if you are declaring this constructor, after the constructor, if you are declaring the data and next, it means you are going to use a linked list in your program. So that is the difference between these two. Are we clear about this?
Yes, sir.
Yes. So basic difference. So be aware of that. In your second unit, if they are asking in the stack or queue, definitely you want to go with this linked list concept. And now, and you can see here I am defining a function, defining a linked list. It means I have creating a linked list over here. This is an empty linked list, and it will consist of two parts. One is data, and another one is next. And the next one value will be none. Is that right?
Yes, sir.
Yes. So in the stack, after that it will go to the stack. So self dot head is equal to none. Self, this is a head, and self dot head will be none, so it will be consist of none value. In this line it will be represented, right?
Yes, sir.
Yes. And it will be checking whether this and this function def is empty. It will be checking whether the list is empty, whether the stack is empty or not. Here I am giving that self dot head is equal to none, return to, else return false. So here the value will be none, so it will be returning to. If suppose before the all push operation, if you are checking the list is empty or not, then it will be finding out yes, the stack is empty. Like that, it will be returning a function value called true. Clear about this line? Clear about this? Still this?
Okay.
Yes. And again, what is the push operation? The push operations, in the sense we have already initialized the stack. We have already initialized this stack. So self dot head is equal to none. Yes, the self dot head is none. You just imagine I am giving an input of 1, 2, and 3. So the self dot head is equal to none. So we are already having a null value over here. Yes, that is a null. So self dot head is equal to node of data. So this will be the head value that I have assigned. So this will be the head value. And else part will be up here. New node is equal to node of data. The first node will be 1. So this is 1, and this is the next node. And here this will be assigned as new node. Right? Clear about this? So if it is none, the self dot head is equal to node of data. So it is a head. The first node will be there. Right? Have you clear, or I have to explain this? Yes. So here new node is equal to node of data, and new node dot next is equal to self dot head. New node dot next is equal to, now this head will be removed, and here this head will be insertion, and self dot head is equal to new node. So head will be the new node, and after the same iteration, this 2 will be there, and n will be there, and again this head will be removed, and here this head will be allotted, and after that this 3 will be allotted with the null character. In the previous example, in the linked list, circular linked list, and the doubly linked list, what will happen is the head will be remain constant in the first node, right? Yes. 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 So here the head is keep on changing to the new node. What is the purpose? So only difference between the circular linked list, single linked list, mean that the head is keep on, the head will be remain constant in the first node whatever we have inserted, and in the stack operation, the head is keep on changing to the next node. So what is the purpose of this? So I will tell you this. So this is the stack. We are inserting the first element. Now this will be the head. And again we are inserting the second element. So this will be the head. So this is the process. Again we are inserting the third element. This will be the head. And again we are inserting the fourth element. This will be the head. Now we are going to pop any one of the element. The fourth element will be popped, right? First. Yes. Yes. It means that we are giving the head value for the new node. It means when you are popping those last element, based upon this head value, we can pop those elements. Yes. Clear? Why the head has been changed from each and every node? So this is simple concept. There is no deviation between this. In the circular linked list and doubly linked list, the head will be remain constant at the first node, and in this stack process, the head will be changed according to the new node whatever we have added, and the last element, the last node will be your head node that was defined. The last node will be your head node. Clear about this, or I want to explain it again?
Sir, it means that it is to remove using pop function, it is changing the head function.
For using the pop function, we have used that we want to remove the head first. It means keep on updating the head process. The last function also it will be head as of now, and here the head function will be removed first. And self.head.next will be this. The previous head function will act as a last function. So I will tell you that. You just clearly listen. One thing. In the circular linked list, I will tell you this circular linked list or doubly linked list. So this will be act as a head, and this will be act as a tail. And if you are inserting another element, this head will be remain constant. This tail will be, this last element will act as a tail, right? Yes. Yes. So here, what is happening in the stack? What is happening in the stack is the stack process, which will be consist of, we want to remove the last element. So it means first element inserted, I am giving a value of head to the first element, and second element has been inserted. Again, I am giving the value. This value has been changed and giving here to the head value, and here we are inserting a third element, and I am giving the head value. And if I am going to pop element in the stack, what it means, I can directly access this head and I can pop those head, right? Yes.
Yes, sir.
Yes. So if suppose I am giving three element 1, 2, and 3. So here first iteration this will be the head, and second iteration this will be the head, and if you are inserting the third element, this will be the head. So this will not a head. And if I want to pop those elements, I can directly access this head element and I can pop this. And after popping the head element, the previous head will be act as your head, right? And again, I want to pop one more thing. So this will be popped, and this previous element will act as a head. And again, I want to access this. This will be popped, and there is no element in this, and it will produce the null element. Yes.
Yes, sir.
Yes. So that is the thing I have used here. So new element is equal to node of data, and new node.text is equal to self.head, and self.head is equal to new node. So you can do an operation by your own by using one of an example whatever I have done here. You assign a value for a new node of data, new node of text, and likewise it is a push operation. And you can go with the pop operation. You can see here I have defined a variable called pop node dot is equal to self.head. So it means that last node will be your self.head. So pop node is equal to self.head. So I am going to create a pop, and self.head is equal to self.head.next. So the next head what we have described will act as a head, and pop.next is equal to none. So this value will be none. So the next value will be none, and it will be returning the pop node of data. So this node has been popped, and this 3 will be displayed in your function. And for peak function, so it means that top value displayed function self is empty, return none. So first it will be check whether the self is empty or not. So it will be return none, and if it is not empty, it will return the head.data. So whatever data that was described as a head in the previous pointer, that data will be displayed. So now this 3 has been popped over here, and this will be the head. The 2 will be the head. For this 2, the data will be consist of 2. So this 2 will be displayed at the peak function. It means that we are going to display at top node functions. And for printing this and each and every iteration, so here the self.head was declared as an iteration node. For each and every iteration, when the data is entered in your program, thus that iteration node will be displayed based upon the condition what we have given. So this is the object that we have created. My stack is my object. In this my stack, I am going to use a push function with the whether we have. So here the push function, we are directly given an integer number here. So it means we have already declared this self value, and after that the data functions is there. So each and individual value which will be coming under the data, and it will be doing the process. So we are doing a push operation, we are displaying an operation, and we are displaying the peak operation, and after that we are doing two pop operation, and we are displaying that, and after the displaying, the peak operation will be displayed. So here with the display option will be displayed of 11, 22, 33 and 44, and the peak will be, what is the peak now? So in the stack we having an element called 11, 22, 33 and 44. What is the peak value? It means the top value. Yes, the 44 will be your top value. That means last inserted element is there, so it will be a top 44. And two pop operation will be there. So the 44 and 33 will be removed. And after that, the display function were used. And now the 11 and 12 will be displayed. In that 11 and 12, the peak value will be?
22.
Yes, 20. So in 11 and 12, the peak value will be 22. So if you are asking, this is the condition, I will share you this. Once again, I am telling this, how I am explaining this in the node like that, I am explaining this else part. You just take one number and allot it as a new node, and data, the new node of data will be stored in a new node. Like new node dot next is equal to self dot head. So new node dot next is equal to self dot head, and self dot head is equal to new node. Likewise, each and individual new node will be created like in this process to do a push operation, and new node value will be given in the first of a constructor that we have created in an object. Based upon this, the new node will be already stored here, and for each and every iteration, the new node will be coming over here. And this pop node, it will remove the head element, last head element, and after removing the head element, the self dot head dot next, it means that previous head value will act as a head. Previous head value will act as a head, and it will be storing in the process. So this is the basic concept. So if you are going with those lines of code in your own way, then you can be able to understand easily. So have you understand the concept first? That I want to know that. Have you understand the concept? Have you understand the concept? What is this? Have you understand the concept, or I want to explain? So this line push and pop operation, definitely if you are doing or working the problem only, you can able to understand clearly 100%. But the concept, what I am explained is this thing. So that's why I'm asking, have you understand the concept or what? Yes. So if you are, so this is the question. So I can't able to take 5 to, what is the question bank? How many question has been given to in the part B option?
5.
5. Yes. For this subject, you no need of question banks and all the questions will be asked in the question banks. So for still unit number 1 to Q operation, all the question will be asked. In your question, all the questions will be there. So don't worry about that. So when you are going, if I am asking the question in the first unit related to the stack, no need to define the linked list. You can write the stack operation. That is a simple program. That will be enough. So if I am asking the question in the second unit, then you want to represent the self.data, self.next like that. Clear? Any doubts?